This is question number 19 on the January 2017 Algebra 2 Regents. And what we have here is actually a little bit of a complicated question because it involves four different functions and basically kind of four different questions. So let's take a look. Which statement regarding the graphs of the functions below is untrue? And these are the four functions, and these are the four statements. Well, let's start off with choice number one. We're looking for the one that is untrue. So we have f of x and j of x have a maximum value of 3. F of x has a maximum y value of 3. Let's determine that first. Well, we should know that f of x is 3 sine of 2x has an amplitude of 3. So what that means is we're going to go from 0 to 3. I'm not that concerned about the frequency there because that's not going to affect our maximum value. Now let's say you don't know that. We could certainly graph this function and take a look. Clear out whatever you have in here now. And graph it. Now, you might get a funky looking graph like this, which is obviously not a sine function. And the reason for that is we're probably in degree mode, and we should be in radians for the purpose of this question. So let's take a look now with radians, and now we graph it. Okay, I still can't clearly see the maximum, so I'm going to make one more change here. Change this to zoom trig. And we can take a look at the maximum value here. So what we can do is trace it. That sure looks like it's 3. And we could also use the maximum feature in second calc. Left bound to left of the function, right bound, and then the guess is irrelevant. And we do get a y of 3. So that one works. Let's take a look at j of x. Now, this is an inverted absolute value function, so it's going to look something like that. And this would be the maximum value. Well, think about this. The j of x has a maximum value here of, well, the absolute value itself has a minimum value of 0. So because it's negative, the maximum value of that would be 0, and then we've shifted it up 3 units. So the maximum of that would indeed be 3, and again, we can just graph this. So what I'm going to do, because I may need this for some of the other stuff, is actually just graph this one here, and then hide the other functions. So to get absolute value, go to Math, Numbers, ABS, and the newer versions of the calculator, this will actually show as an absolute value with the vertical lines rather than what I have here. So now what I'm going to do is I'm just going to hide this piece just so I can see the second function. And that sure looks like it's got a maximum value of 3. And again, kind of pin it to there. You see it's pretty close to 3. And if we are to use the second calc maximum, we'll go left of the max, then right of the max, and ignore the guess, just hit yes. 2.99999, that's the calculator's approximation for 3. So these two both check out. And again, j of x is this function here. Let's try the next one. We have f of x, h of x, and j of x. They only have one y-intercept. Well, this is actually really easy to check. First of all, from our previous graphs, we should know that they have a y-intercept, at least the f of x and the j of x. Now, the h of x we would have to graph. Now, in the newer features, we can actually graph the log base 2 of x. But because this calculator version here does not have that, we would have to graph just basically something like log of x and see if it gives us a pretty analogous graph. Okay. Well, does that have a y-intercept? Let's hit the table and realize that when we put in an x, we get an error for y when we put in an x of 0. So for this, I want you to remember here that a y-intercept means that the x value of the function is 0. So if I put in a 0 into the x to try to get the y-intercept, I'm going to get the log base 2 of 0, and we should remember that you can't take the log of 0, because this is essentially saying that 2 to the h of 0 is 0, and there's nothing that I can raise the 2 to get 0. So the answer is 2. It's not possible to produce a y-intercept from a log function. And at this point, since we know that is certainly untrue, you don't actually even need to check the other two.